Some extra balancing equations practice is what I wrote as my high-tech heading. And we're going, because the toughest by far, Jessica, is going from words to skeleton to formula. You got a periodic table? We're good? So here we go. It says lithium and oxygen become lithium oxide. Just write down the first one. Don't write down the next one because we're going to need a fair chunk of room.
Sorry to interrupt. Can I have a student?
Yep, go ahead.
Okay.
Lithium. Periodic table. What's its symbol? Li. And it's all by itself, so that makes it very convenient.
Thank you.
What does the word and mean in an equation? What do I write? No, not an arrow. A plus. Plus what? Why O2? Why not just O? There's those 7 molecules that when they're by themselves are never by themselves. Remember the word we gave you was Hofbrinkel, so Hof, hydrogen, O, oxygen. Write it out, and you can remember it that way. We also noticed they form a number 7 on the periodic table, except for hydrogen, which is the weird one. So it's going to be O2. What am I going to write for a becomes? Arrow. Now it says lithium oxide. Lithium oxide, though, is not LiO. As soon as they give me a name, I need to make sure that that formula is written correctly. How do I do that? I'm going to go off in the margin somewhere, tie, and crisscross. So I'm going to go off in the margin. I'll change colors. I know Li is lithium. What's the charge on lithium? 1. Lithium, is it a metal or is it a... In other words, is this ionic or covalent? Is lithium on the left side of the periodic table or the right side? It's ionic, okay. So I'm going to think about my ionic naming conventions, which means it's not going to be di or tetra or anything like that. Oxygen. O. What's the charge on oxygen? 2. Crisscross. Okay, it's going to be Li2O. Am I going to write the 1? No. No. Okay, now, Hannah, we call this a skeleton equation. Why is it called a skeleton equation? I have the little individual formulas right, but I'm telling you I don't have the atoms balanced. The law of conservation of mass says the number of atoms before has to equal the number of atoms after. How do I figure that out? I make a little list. Let's go blue. Hannah, on the left side, how many Li's are there right now? How many O's are there right now? 2. On the right side, how many Li's are there right now? 2. How many O's are there right now? 1. Are we balanced? I say no. Now, to balance an equation, Brad, I am not allowed to add numbers here. I'm not allowed to add, remember what we called those? It began with the word sub. Someone's right. Subscripts. Okay, I'm not allowed to change the subscripts. All I can do is I can add, and I can use this Math 10 word now, coefficients, the numbers in front. So I can add numbers. Don't write this down, but I can add numbers there, or there, or there. I'm going to get rid of the boxes because that really clutters things up. Okay, Amy, what do you want to balance first, lithium or oxygen? Okay, let's try lithium first. I think the easy way to balance lithium is going to say, well, how many do I have on the left right now? How many do I have on the right? How about if I say to myself, let's get 2 there by putting 2 there. Okay. Are my lithiums, and also that 2 doesn't affect the oxygen because the oxygen is a completely separate reactant. Are my lithiums is balanced? Yep. What about my oxygens? Okay, let's balance those. How can I balance those? Put a 2 right here. Now, that's going to give me 2 oxygens, but what else is that going to do? It's going to give me 4 lithiums because it was an Li2 and I put a 2 in front of it. Are we balanced? Not yet. How can I balance this now? Put another 2 right there. Put another 2 right there, but instead of writing 2 times 2, what would I write instead? Is it smart to do these in pencil? Yes, because you can do this. And this is my balanced equation. I have 4 lithiums on the right. I have 4 lithiums on the left. I have 2 oxygens on the right, Hayden. I got 2 oxygens on the left. And I also made sure that this here is written properly. I got the subscript right before I got into it. Mr. Dewick, this is tough. Yes, it's about as tough as it gets. That's a medium tough question. Let's try a nasty one. This one here is polyatomic. That means it's got some of those weird ones from the back of your periodic table of the elements sheets. This one here is tricky enough that I'm going to cheat and open the other textbook that I was using to make sure I don't botch it like I did in my last lesson. Sorry about that. Sorry, what? Number 2. And then we're going to do number 3, but right now, number 2. So, sodium nitrite, no, sorry, careful, read, Mr. Dewick. Sodium nitrate becomes sodium nitrite and oxygen. Okay, here we go. And this is from page 200 and something. Sorry, I'm going to my answer sheet to make sure I get the formula right, because if I don't get the skeleton equation right, then the rest is kind of yucky. Sodium, is it a metal or not? Sodium is a metal. It's on the left side. So this is going to be ionic. Let's write down the symbols first. Sodium is, that one I've got memorized. It's Na, yes? Nitrate is from the back of your sheet. NO. And I'll put it in brackets for now, NO3. Now, we can't stop here. We have to make sure we have the subscripts correct. So let's go off in the margin. How about right here? I'm going to write down Na. What's the charge on Na? I'm going to crisscross. 1. I'm going to write NO3. I didn't leave myself enough room, Mr. Dewick. Na bracket NO3. What's the charge on NO3? 1 as well? Oh, is that one already crisscrossed? Good. That's nice. Back to my skeleton. Hannah, what does becomes? What do I write for that? Sodium nitrite. That's going to be Na. Nitrite, that's also on my sheet. Before we go further, we got to crisscross this one. Let's do that off in the margin here. Na, we already said, was 1. What's NO2? Also 1? They're both 1? Oh, that's nice. So I don't need to add subscripts? Cool. And, O2. This is already a tough one. But I figure if we get the tough ones, then the easy ones will take care of themselves. Let's make our list carefully here. So what did I go with for colors, Mr. Dewick? Oh, I'm changing colors now. Let's go red. How many sodiums, how many NAs on the left-hand side right now? How many N's on the left-hand side? 1. How many O's on the left-hand side? 3. How many NAs on the right-hand side? 1. And by the way, I was pointing this out, I think, to Amy the other day. If you go Na, N, and O on the left, go in the same order on the right. It's way easier to move your eyes back and forth and spot stuff. So I'm going to do my N's next. How many N's are there? 1. 2? 1, isn't it? How many O's are there? 4. Let me make sure I got this equation correct, Mr. Dewick. Where did I steal this from? Where did I steal this from? NaNO3, NaNO2 plus O2. Woohoo, I got it right. All right. Hey, what's unbalanced? Only one thing. Which one? Okay. How many do I have on the left? 3. How many do I have on the right? How many am I going to want to get them to match? Oh, and those of you that are in Math 10, I think we call this an LCM, a least common multiple, which some of you are starting to do in a couple of days. How many do I need? It's going to be 12, isn't it? So, if I want 12 over here, how can I get 12? This is tough. How can I get 12 over here? Well, I got oxygen in two different places. If I just go and put, don't write this down, if I put a 6 there, how many oxygens will I really have? I'll have 12 plus 2 is, yeesh, don't want to do that. Was that a suggestion? Any suggestions? Okay, now we're going to guess in pencil. Yeah? Say that again. 3 on each of them. So put 3 here for 6 and 3 here for 6, and that would give me 12. That would change what? Okay. I think so. Here's what I would try first. If I put a 5 there, how many do I have on the left-hand side right now? How many do I have on the right-hand side? See the 12? Let's try that. How could I get 12 over here? Put a 4 there. 4 times 3, 12. Oh. Kenzie, that changed everything else, though, now, too. How many NAs do I have now? 4, right? How many N's do I have? 4, right? Yeesh. Okay. How many N's and NAs do I have on the left-hand side, Dane? How many NAs do I have on the left-hand side right now? 4. How many do I have on the right-hand side? How can I get 4 there? Let's try putting a 4 there, and that's going to give me 4, 4. It's going to change the oxygens. How many oxygens do I have over here on the right-hand side now? 20. How many would I like to have? 12. Can I get 12 here? Well, how many do I have right here? 8. How many would I like right here then? If this is 8, how many would I like right here? Can I turn that into a 4? Can I turn that into 4 oxygens somehow? Make that, erase it, Mr. Dewitt, because you did this in pencil. Make that a 2, is that what you're saying? And that would give me, let's pull back, let's zoom up. This is tough. Let's see if this works. Let's double check. How many NAs on the left? 4. Brad, how many NAs on the right? 4. Check. How many N's on the left? How many N's on the right? Okay, now the oxygens. Here we go. How many O's on the left? 12. How many O's on the right? 8 plus 4 is? Works. There is a guess and check approach to these. Now, as you do a bunch of these, some of you will start, there's a bit of an art to them. You'll start to notice patterns, or your brain will just start to see the answer because it's spotted stuff. Last one, and then I'm going to give you a practice sheet and I'm shutting up. Aluminum and lead 2 nitrate becomes aluminum nitrate and lead 2. By the way, number 2, that's a tough question. when you're crossing out and recrossing out and crossing out. What I am saying, Kenzie, is don't quit and keep your eyes open. Sometimes you may have put a bigger subscript in a coefficient in front of something, Hayden. Don't be scared to cross out and put a smaller one in there if that makes your life easier. Got a periodic table in front of you? Or you can look at aluminum. What's the symbol, my friend?
Yeah.
It is. Is aluminum multivalent or not? Does it have more than one charge on it sitting there, or is it just, oh, good. What am I going to write for the word and? What am I going to write? Plus. Lead. Lead is Pb. Nitrate. That's from the back because it's not nitride. Nitrate. NO3? Oh, I need to make sure the subscripts are right. So I'm going to have to crisscross off in the margins somewhere. Once again, Mr. Dewick, you didn't leave yourself enough room. So lead, what's the charge on lead? Well, lead is multivalent. There's two possible charges, isn't there? How do I know which one they want me to use? Oh, they got the Roman numerals. So that actually makes it, it looks tougher. Roman numerals actually make it easier. It's going to be a 2 up there. And what's the charge on NO3, on nitrate? 1? Change colors, Mr. Dewick. Pb 2, NO3 1. When I crisscross, that means I'm going to have 2 of those. Oh, and Justine, 1 of the leads. Am I going to write the 1? No. You with me? You looked like you were zoning out there. I saw the eyes shut for a second. Ah! Nothing? No? Yeah, that's on the internet now too. What I'm going to write for becomes, Ty?
The arrow.
Turns into react, yeah. Aluminum nitrate. Okay. Brady, what am I going to write for aluminum? I agree. Nitrate. Oh, that was NO3? We need to crisscross to make sure that these subscripts are right. Let's do that off in the margin. Brady, what's the charge on Al? 3? And the charge on nitrate, I think we said was 1. Is that right? Crisscross. So it's going to be 3 of those and 1 of those, but I'm not going to bother putting a 1 right there. I have to add 3 on the other side. Isn't it like that? Oh, I will eventually. I'm not balancing yet. I'm just doing the skeleton right now. Don't get ahead of yourself. I didn't add 3. Oh, here? But it's by itself, so I don't need to do anything. Yeah. I didn't need to crisscross because it's by itself. I'll show you what I mean. Josh, what is the word and replaced with? Plus. And the last thing here is lead. I know it's lead too because it says, but is it by itself? Who cares about crisscrossing? It's by itself. You with me? Now let's make our list of everything that's here. So let's change colors, Mr. Dewick. Josh, on the left, how many ALs are there? On the left, how many ALs are there? Just 1. How many PB leads are there? 1. How many N's are there? Careful. 2. Yes? How many O's are there? Not 3. 6. See it? 2 and 3. 2 times 3. Yes? Hannah, on the right-hand side, how many ALs are there? Oh, that's nice. Maybe we're done. How many N's are there? Dope! Oh, I said go in the same order, Mr. Dewick, so why don't I write the N right here? How many PBs are there? Because that's what I did next on the left-hand side. 1, I like that. How many O's are there? 9, or are you German saying no? Yeah, 9. I'll never get tired of that joke. Are we balanced? Curtis, are we balanced? No. Nope. Let's try the nitrogens, because that looks a little less scary than the oxygens. Curtis, I have 2 on the left, 3 on the right. Hey, what number do those have in common? How many do I want to get? 6. Or in math speak, what's the least common multiple? 6. So, Curtis, my friend, how can I turn 2 into 6? So, if I put a 3 right there, you're saying that's going to give me 6 of those. That's also going to give me 3 of those. And that's going to give me how many of those? Let's see. 6 times 3? 18. Okay. But let's continue on. We're hoping the oxygens take care of themselves because they're usually the trickier ones. How can I change the 3 n's into 6? So put a 2 in the front right there. 6. How many ALs now? How many N's? Oh, we already did the N's. How many O's now? 8. Oh! Oh, shoot. We're not quite balanced. Now what? Oh, you're saying I got 3 leads on the left, 1 on the right, but you're saying if I put a 3 there, I got 3? Are we balanced? No. Now what? Oh, you're saying I got 2 aluminums here. Put 2 there. Laura, are we balanced? Yes. Yes. Ta-da! That's what we're looking at. So what are we working on? I gave you a bunch of stuff last day, and I just got a big review handout. And I'm going to shut up. But those of you who have been watching on the internet may have noticed that I made a mistake on number 2. Bear with me. I'm teaching this for the first time. I'm learning half of this. On number 2, the fact that there is a 4 right here, a 4 right here, and a 2 right here, the fact that all of the reactants and the products have coefficients, and there is, Kenzie, can you see a GCF? We can reduce that. What we can really do is divide by 2, divide by 2, divide by 2. The correct answer is 2 of those, and 1 of those. So what you have to do when you're done, Amy, is glance at your answer, or if when you're checking your answers, you notice it doesn't quite match, see if you can reduce your answer. If every single thing has a coefficient, not just an invisible 1, but a number in front of it, and you find a GCF that you can pull out, then you can reduce it. Now, if everything does not have a coefficient, in other words, if there is an invisible 1 in front of everything, then there is no GCF. The GCF is just 1. So that's why, for example, on here, did the 4 and the 2 reduce? No. Why? What number's right there? It's invisible. A 1. So it doesn't reduce. Is that okay? Ty, thank you. Folks, sorry. Get used to me making mistakes as I learn this. Now I'm going to stop this video.